Hey guys, welcome to Wacky Inventions, and this is the video series where I'll be talking about wacky ideas I have that I think might work and be practical as potential solutions for the energy or whatever engineering problems of tomorrow. And today I'm going to talk about Boron Fission Reactor. Okay, what's boron and what's fission? So boron is a element, letter B. There's 5 protons and usually 10 or 11 neutrons. 5 protons and 5 to 6 neutrons. So it comes in mainly 2 stable isotopes, boron 10 and boron 11. What it's normally used for? It's normally used for neutron poison. What does that mean? So in a nuclear reactor, you have fission, right? And fission is a chain reaction, and that is directly dependent on neutron concentration. So thermal neutron concentration. So what boron does is that it absorbs boron, specifically boron 10, absorbs the neutron and so decreases the concentration of thermal neutrons, and that actually slows down the reaction in a nuclear reactor. However, in doing so, it does something quite interesting. So let's take a look at what happens when boron 10, which is the main neutron poison, captures a neutron. So boron 10 captures a neutron and gives lithium 7 plus an alpha particle, which is just helium. Okay, and along with that, it releases a certain amount of energy. And how much energy is that? It can be anywhere from 2.31 to 2.79 MeV. Now, if you understand nuclear reactions, that's about what you get. And in comparison, we can look at a typical uranium fission. So uranium fission will give some typical radioactive fission products. Plus 177. Okay, and a fusion reaction that's typically available in a tokamak. Oh, sorry, it should be this: deuterium and tritium. It comes a helium or alpha plus a neutron. Okay, so this is about 3.5 MeV. The neutron itself, so let's write that again, 21D plus 31T becomes 42 helium plus neutron. This neutron is 14.1 MeV. Okay, so this is a what do you call that? A fusion reaction. So to compare to boron, this is about 2 to 3 MeV. And what does that tell you? Now this is about what do you call that? 6 to 7 times less, but that means a lot still. What it means is that this stuff is potential nuclear fuel. Ooh, got something a little interesting there. Of course, it's not usually a nuclear fuel. it is a neutron poison. So normally people won't think of it as a nuclear fuel, but it is. It could be a potential nuclear fuel, as I think Dr. Robert Bussard is the name. Okay. So what he has done, he has described a very interesting invention, and what it does is that boron 11 plus a proton, it reacts to give 3 alpha particles plus energy. Okay? So what happens here is essentially when these two things fuse, they split again. When these two nuclei fuse, they split again to give energy. So this is kind of a fusion and then a fission reaction. Okay, but the main thing is that helium is produced from cheaper boron, because helium is usually quite expensive, if I'm not wrong, plus energy. And what do you get? You get energy, and you don't need the intense magnetic fields of a tokamak. Yeah, you don't need the magnetic fields of confinement. All you have to do is just fire a beam of protons at these boron 11. However, can't you do the same for boron 10? If you just use an ADS system, it's called Accelerator driven system, to produce all these neutrons, can't you just produce the alpha and the lithium all the same? I mean, someone has to do the math on this. I don't know whether it'll actually work. But this is an interesting idea, because what this means is that you have a nuclear fission reactor that produces 0 long-lived radioactive waste, and well, the products are actually quite valuable, because helium is valuable, and this you can find in the form of borax that goes for around US 460 to 640 per ton. Okay, helium, it goes for about, I think, 68 per cylinder. And one cylinder is about 80 liters. It's nowhere near a ton. So you can produce a lot of helium from just this much boron. If you can produce that much helium, then you're going to make lots of money as well, in addition to all this energy. And that's not including the lithium you can sell. And depending on what chemical form this boron is in, you can be selling lithium hydroxide, pure lithium, or some other chemical form of lithium. Alright. So that's just one idea for the use of boron in a fission reactor, or a boron fission reactor. The other thing I'd like to talk about, an interesting idea, for those who are studying nuclear reactors, I mean, you know boron is a poison, right? And what if you have a reactor with your typical moderators and a graphite reflector here? And you know, everything about this reflector is meant to reflect neutrons back into the nuclear reactor. Inevitably though, some thermal neutrons actually leak out. And this is actually waste. Now, do you want that waste, in fact? Or do you want to monetize every neutron? Of course you want to monetize everything if it is possible. I mean, that's the mentality of people doing crude oil. Crude oil people, they monetize everything in the barrel, from the asphalt all the way to gasoline. So if you want to monetize that, what do you call that, neutron, you want to monetize every single neutron, well, what can you do? One thing you can do is just outside this reflector, put a blanket of boron. You put a blanket of boron in the form of maybe boron carbide. I've seen some moderators and control rods, they're like that. And what do? When the neutrons hit this thing, there's going to be helium or alpha particle plus heat, lithium plus heat. What can you do with this heat? This heat you can recover for energy or for more energy. And the net result is no neutron wasted. Now, isn't that a good idea? You can try something like that. It is very similar in concept to heat integration and pinch analysis if you have done those things before, but that's just to give you a thought on, well, it can give you a thought to increasing the fuel efficiency of a nuclear reactor, regardless of what kind of nuclear reactor you're using, solid fuel, liquid fuel, any kind of that. So, just some food for thought, some energy, some interesting idea to share with you. And if you're going to use it for your invention, I really appreciate it if you cite me or something. But anyway, I don't know how you probably want to monetize this, but it is interesting. It is quite interesting. So yeah, do stay tuned for more wacky ideas. There's off the board drawings and preliminary ideas. Preliminary ideas for a better tomorrow. Okay, so that's all I have for you for today's wacky idea topic. See you again next time.